Hi, welcome to our second lesson in Nature's Chemistry, NC002, bonding in organic compounds. Now, uh, it's important to understand the bonding numbers, as we call them, of the different elements that are involved in organic chemistry, but there aren't very many of those elements, so it's not really much to worry about. But what I'm going to do is I'm going to explain some of the basics behind their bonding. And we're going to revise valency, which we learned about in Unit 1, and we're going to revise basically how covalent bonding works. It shares electrons, remember. So when two elements come together, they share electrons. We'll see if we can do that in 7 minutes. So let's look at the whiteboard for a second. And what I'm going to do first of all is I'm going to put the periodic table in front of you. Because what I've done is I've coloured in all the elements that are involved in our organic chemistry. Now, carbon, of course, is highlighted in yellow here. It's the most important one. It's the one that forms the structure, the basic skeleton, the scaffold, if you like, of all organic molecules. That's fine. Hydrogen and oxygen are our two next most important elements. They're the ones that are going to feature in most of our organic chemistry learning. But the halogens, I've coloured them all green here, because they're a little bit interchangeable. Different halogens will give you different properties, but they all appear in chemical compounds, in organic compounds, the same way. They're all in green here. And we're not going to mention much about nitrogen and phosphorus in our chemistry learning, but they're incredibly important for the organic molecules of living things. Nitrogen and phosphorus are required elements for all life, and they're very important there. So I've highlighted them anyway. So we're just going to look at these elements and what kind of bonding they do. So let's start with carbon. We remember that carbon has a valency of 4. We'll just pop back to the periodic table. Remember our valency rules. Hydrogen, group 1, valency 1, group 2, valency 2, group 3, valency 3, group 4, valency 4, group 5, valency 3 again, group 6, valency 2, and group 7, valency 1. So 1, 2, 3, 4, 3, 2, 1. Remember to write that in your data book as soon as you get it. So carbon has a valency of 4. It means that it makes essentially 4 bonds. And if we look at the electron arrangement of carbon's valence shell, its outer shell, we see that it has 4 electrons. 1, 2, 3, 4. That leaves room for another 4 electrons. So it will make 4 bonds, because it can share an electron with 4 other things that are giving up electrons. So 4 bonds. Hydrogen has 1 electron in its valence shell. It only has 1 shell and has 1 electron in its valence shell. But because its valence shell is the first shell, which can only take 2 electrons, it can add 1 electron and it will make 1 bond. So you see the pattern here. You can squeeze in 4 electrons, you get 4 bonds. You squeeze in 1 electron, you get 1 bond. Oxygen, let's look at its electrons. It has 6 electrons in its valence shell. So we'll just pop them in. 1, 2, 3, 4. Well, there's 4 in. Now remember what happens with electrons. Once we go past 4, they start pairing up. So the next electron will pair up with that one, and the 6th electron will pair up with that one, leaving 2 spare electrons. Now these are the electrons that are available for sharing. These electrons here don't get shared because they're already paired up. So we need to put 2 electrons here to get to the magic number of 8, and that will give us 2 bonds. Now these unshared pairs are important for the structure of oxygen when it makes covalent bonding. So we'll come to that in a later lesson. Nitrogen, remember, has 5 electrons in its outer shell. So 1, 2, 3, 4. And of course the next one has to go with a pair. So that's 5. That pair is not available for bonding. These individual electrons are, so we can put 3 electrons. If it can share 3 electrons, it can make up to 3 bonds. Okay, and finally we'll take fluorine. Fluorine is an example of a halogen. all the halogens are the same. They're all in the same group of the periodic table. So they all have 7 electrons in their outer shells. So 1, 2, 3, 4. And they pair up 5, 6, 7, leaving 1 unpaired electron, which can be shared with another element. So that gives us 1 electron that we can add to this. Gets them up to 8, which is the magic number. And they make 1 bond. Now, chlorine, iodine, and bromine do the same thing as fluorine. I don't need to write them all in. So let's just look at an example of the bonding. If we remember, so I'm going to take a different colored pen here. Let me get a couple of colors. Red, I think, will be handy, and orange will be handy to show up nicely on this sheet. Orange and red, a bit hard to see. I think, where's my green? Do I have a green somewhere? I might have a green. There it is. Okay, we'll do red and green. Sorry if anybody's colorblind. I don't think anybody in my class are, but you never know. So if I take my carbon atom, and it has its 4 electrons around it, then what I can do is I can take a hydrogen, and the hydrogen will go here, and its electron, we'll make it red, shares up and pairs up with that electron. And so we get a bond. So the carbon and the hydrogen are bonded. So at the moment, the carbon is still free to make 3 more bonds. So what I can do is I can pop on 3 more hydrogens. All right? So there we go, hydrogen, hydrogen, hydrogen. And the red electrons are coming from the hydrogen atoms. The green electrons are coming from the carbon atom. We have 1 carbon atom sharing 4 electrons. We have 4 hydrogen atoms sharing 1 electron each. The total number of electrons, you can count them up, is 8. So I get a compound which we call methane. And that is the simplest organic molecule. Anyway, a very quick run through bonding in organic compounds. I hope you enjoyed that lesson, and we're going to move on in our next lesson to look at double bonding and triple bonding between carbon atoms, which is an interesting topic in itself. So I hope you got everything out of that. If you didn't follow it, try watching it again, and if you have any questions, put them in the comments below. See you next lesson.